start with the decoder. Let me use the laser pointer first. Okay. So this is a typical block diagram of decoder. So this is our input. We have here two input and we have four output, right? So the general equation is like if you have n input, you have 2 to the power n output. If n equals 2, so if you have 2 input, then 2 to the power 2 4 output, which is validating this diagram, right? So we have 2 input, 4 output. A decoder selects of twice an output by decoding the binary value on the n input. The decoder generates all of the midterms of the n input values. Exactly one output will be active for each combination of the input. Okay, so what does basically the active means? So we'll discuss it in the next slide as well. So this is active high output decoder, right? So it says active high. So what does this active high mean? That means the output will be activated on active high values, right? If it has 1, then it will be activated. Active low output means if it is 0, then it will be activated. Something like that. Okay. So we have two input, 4 output. So this is our MSB, this is our LSB, A and B. Right? So most significant and least significant bit. So with 2 bit we have 4 combinations 0, 0 to 1, 1. Okay, so if we have 0, 0, so then we'll be selecting output 0. If 0, 1, then selecting output 1 or X. If 1, 0, then output 2 or Y, and 1, 1, then output 3, right? So if you take the W, X, Y, Z, so that will be W equals, if you look at here, A prime dot B prime, and for the next one, A prime B, third one will be A B prime, and fourth one will be A B. So this is the equation for active high output decoder. This is our active low, so that's why we have that bubble. So bubble means active low, active low output, right? So that means for 0 it will be activated. So if you have 0, 0, then our output will be W. So that's why W is 0 as it is active. So other is active. 0, 1 it will be X 0. Other is 1. 1, 0 Y is 0. Means activated. 1, 1 and Z is 0. Other is 1. So this is just the inversion of the previous equation what we got it here in the previous slide, right? The same thing. So this is 3 to 8 line decoder. Okay, so 3 to 8 means 3 input and 8 output, right? So 2 to the power 3 means 8 output we can get. Okay, so this is our ABC, the input. We have 8 combinations 0 to 7. The same as previous. If we have 0, 0, then it is selecting Y0. If 0, 0, 1, 0, 1, Y1, 1, 0, Y2, 1, 1, Y3, and similarly 1, 1, 1, Y7. So if you write the equation, so Y0 equals, so this is your Y0. So it becomes this one. So A prime, B prime, C prime. Next one is Y1. It becomes A prime, B prime, C, something like for Y7. It becomes 1, 1, 1. So this decoder with enable. Okay. So now you have extra enable pin. So what does it mean? It means when your enable is activated, then your decoder will function. Otherwise, it will not function, right? So that's why we have enable pin here along with your two input A and B, and you have the 4 output as discussed earlier. So when our enable is 1, then it will be activated, and when our enable is 0, it will be not activated. It doesn't really matter what your X and Y is, it will not give you any value output. So that's why if disabled, it means en 0, it will not work. If en 1, it will work. So it will work for 4 combinations 0 0 0 1 1 0 1 1. So for all of the cases en is 1. So if en 1, then it will be activated, right? Other things are pretty similar, like 0 0, it will be selecting output 0 on w, 0 1 x, 1 0 y, 1 on z, something like that, right? So now this is active low enable. Previous one was active high. Now you can see this bubble, right? So this will be activated when you have 0 value. So let's look at here 0. When you have 1, then it will not work. So don't care. When 0 you have 1. For 0 you have 4 combination of AB. For 4 combination of AB it will work. And other things will be pretty similar. For 0 0 it will be selecting W or output 0. For 0 1 it will be selecting X. Similarly for 1 1 selecting Z. But for all of these 4 combination En is 0 as because it is active low enabled. So here you have a couple of exercise. So all of these are your assignment. It says design a 4 to 16 decoder using 2 to 4 decoder. Okay, so you need to design 4 to 16 decoder using 2 to 4 decoder. So this is your assignment. Try to do it by yourself with the concept what we already discussed. Now start with the encoder. Okay, so let me use the laser pointer again. So in the encoder, here you can see you have 4 input, 2 output. So what does it mean? You have 2 to the power n input and you have n output. That means if you have 2 output, you have 2 to the power 2, 4 input. And encoder outputs the binary value of selected or active input. And encoder performs the inversion operation of decoder. So we already discussed about the decoder, so it performs the inverse operation of decoder. What are the issues? The issues are, what if more than one input is activated? We have 4 inputs, so if more than one input activated, then how we'll get the output? This is one of the issues. What if no input are active? So if all of them are disabled, then whether we are getting any output or not. So this is our question, right? So let's find out of this answer. Before going to explain that, we need to know the truth table. Is same as the previous one. We have 4 output, so sorry, 4 input and 2 output, right? So ABCD. So ABCD is 4 output, and for 2 input your Y and Z, right? Okay, so if you have 0 0, so it is selecting your I0 or D. So 0 0 D. If 0 1, it's selecting I1. If 1 0, it's selecting V I2. If 1 1, then selecting A I2, right? This is the typical total. So you can find the equation from here as well. I think. Priority encoder. So we'll find the answer for the previous question here. So if more than one input is active, the higher order input has priority over the lower order input. So this is the answer. So if more than one input active, then higher order will get the priority. Okay. The higher value is encoded on the output. A valid indicator D is encoded to indicate whether or not the output is valid. So this is for the second question. So we will have a valid indicator G. The output is valid when no inputs are, output is invalid actually when no inputs are active. So if no inputs are active, then output is invalid. If at least one input is active, then output is valid. So this is the answer for question 2. Why is the valid indicator needed? So that could be another supplementary question on this stage, right? Okay, look at the priority encoder. So this is 8 to 3 priority encoder. That means we have 8 input, 3 output, right? So we have extra validity. That means when our validity is 0, it will not work. So validity 0 means our A, B, C all are 0, right? So it's not selecting anything. So if our valid bit is 1, then it will be activated. So as we have 3 bit, we can have 7 combinations 0, 0, 0, 0, 1, 0, 1, 0 up to 1, 1, 1. If our valid bit is active, then all of these will work. Say like if you have 0, 0, 0, so it's selecting Y0. If 0, 0, 1, Y1. If 0, 1, 0, so Y2, something like this. If 1, 1, 1, then Y7. Now look at here. So for 0, 0, 0, right? So we are selecting Y0. For 0, 0, 1, we are selecting Y1. But what happens with the Y0? If your Y0 is 1, what will happen? Or if your Y0 is 0? So as we already discussed, the higher order will get the priority. So Y1 will get the priority, right? Among Y0. So that's why your Y0 doesn't really matter whether it is 0 or 1. So Y1 will always get the priority. For this one, Y2 will get the priority. It doesn't really matter what your Y0 or Y1 is. For this one, your Y3 will get the priority because we already discussed higher order will get the priority. Similarly, here your Y7 will get the priority among others, right? Okay.